All right. In the diagram below, they're telling us that triangle DFG is similar to triangle HKM. Because they gave us this similarity statement, we know that, for example, angle D corresponds with angle H, right? Because here they've given us this first vertex listed first and their H. So we know that if D over here measures 59, then we know that H is also going to measure 59, etc. Okay, all the way around. And also, in that same vein, we've got the first two letters of DF, so we know that that side is going to correspond with side HK. And in fact, we will then have the ability to write a similarity, a scale factor based on we can match the vertices and then the corresponding sides. So the first one says the scale factor of HKM to DFG. Notice that they're actually listing the small one first, HKM. So they want us to go small to big, okay? So we just need to be careful about that and see which direction that we're going. So erase all these marks. And let's see what we know. Small to big, we've got, well, which sides do we have matches for? We have a match for this small triangle has this side HK of 18, and HK matches with up here with DF, and DF has a measure of 30. So since we're going small to big, we're going to say 18 over 30. Oops, 30. And of course we need to simplify it. We need to simplify it so we can divide top and bottom by 6, and we get a scale factor of 3 to 5. Okay? That's the scale factor. We always want to simplify it, and we always want to be sure that we're going in the order that they're telling us to. And in this case, they're telling us to start with the small one and then go to the bigger one. Okay? So that's 25. 26 says, what is the measure of angle K? Well, angle K on this triangle, and actually, let me erase the earlier marks. Just it's probably a good idea for me to get out of there all the stuff that doesn't stack up too much. Okay. They want us to know what the measure of angle K is. Well, angle K, if you look up here, angle K, that middle letter corresponds with the middle letter there of F, so that's going to match that angle. We're not given that angle, but we do know that the third angle theorem says that if we know the first two, we can calculate the third. And so what is 70 plus 59, the two angles that they give us? They give us 70 and 59 for that triangle. So 70 plus 59 equals 129. And then if we said, okay, well, we've got to take 180 and take away 129 from it to see what's left. Sorry. That's 7, 10, that's 51 degrees. So I'm going to erase that work now, and we know that that angle should measure 51 degrees. Angle F measures 51 degrees, and therefore, so does angle K. 51 degrees. Yep. Okay. Now, we know that the scale factor of these two triangles is small to big is 3 to 5. For number 27, though, and let me get these marks out of the way. For number 27, they are asking us, they're saying GD, which is big, to MH, which is small. So now they're going in the other direction. Instead of going small to big, they're going big to small. So how does that work? Well, the way that works is we now say, if the scale factor from small to big is 3 to 5, then the scale factor from big, GH, this large side, to small, MH, I'm sorry, GD to MH, that small, will be then a scale factor of 5 to 3. So if it's 3 to 5, small to big, it's big to small, 5 to 3. Okay? And now they want to know what's the measure of MK. So let me get these marks out of the way. Measure of MK, well, what we need to do is then say, okay, we know that we're dealing with a scale factor for small to big of 3 to 5. We'll do this work here. 3 is to 5 as MK is to, what is its corresponding side? If we look on the top, MK corresponds with GF. So GF is 27.5. Okay? So we can then say 5 times whatever MK is equals cross products property 3 times 27.5. And then to solve for MK, we would say divide both sides by 5, and MK will equal 3 times 27.5, all divided by 5. And what is that? Well, if we do the math, and let me zoom in and do the math here, let's say we're doing 3 times 27.5, or let's say 27.5 times 3. If we put 3 on the bottom, we only have one line of numbers. 3 times 5 is 15, carry the 1. 3 times 7 is 21, plus 1 is 22, carry the 1. 3 times 2 is 6, plus 1 is 7, and 1 decimal, 72.5. And now we have to divide that, because remember, that was this. Now it says divided by 5. Okay? So we'll do 72.5 divided by 5. 5 goes into 7 once. 5 goes into 22 4 times. 5 goes into 25 5 times, and there's a decimal right there. Comes straight up. So we get 14.5. I'm sorry, I had to fix this recording. So if we then bring this back to our proper scale, MK is 14.5. 16.5. My apologies. And now I'll get rid of all of that, those calculations. Okay, the last thing we need to do is identify what is side GD. And again, we'll use what the scale factor is that we know, and we'll set it up as a ratio and solve it. That's why these are so powerful, because we can use all these as ratios. So GD is on long side. So if we know we have a scale factor of small to big of 3 to 5, then we say what matches with, what matches with GD. And let's look here on top. G to D, that last letter, the first letter, last letter, and first letter is MH. So that means we've got these two sides. And if we're going small to big, then we'll say 15 for this one, and GD, we could have called it X, but we'll just call it GD. So you get 3 times whatever the measure of GD is equals 5 times 15. Remember, we're doing the cross products property. That times that equals that times that. So to solve for GD, we can divide both sides by 3, and we get GD will be equal to 5 times 15, and then the product of that divided by 3, or GD equals what? So let's do it. Let's do it over here. 15 times 5, 75, and then 75 divided by 3 is 25. So we get GD measures 25, and that's it. Lots of calculations, but all pretty straightforward in terms of what it is that you need to do. You're going to set these all up as proportions, and then solve for whatever the missing value is. And you've just got to be really careful that you're always consistently going small to big or big to small, whatever the situation requires.